Hello, here we are doing more algebra, section 9.5, factoring differences of squares. And difference of squares is just as it means, just as it sounds. If I have a squared minus b squared, that's what a difference of squares is. You got a subtraction problem, and one is squared, just another one is squared. It's just a difference of squares, and that's exactly what it means. That follows a pattern to factor these. All right, a plus b and a minus b. So you just pretty much take the square of the first one and the square of the second one. One's an addition, other one is subtraction. And you remember from chapter 8, when we multiply these out using FOIL, you would have a times a, which is a squared. A times negative b is negative ab. B times a was positive ab. And those would cancel in the middle. And when you simplify this, you had a squared minus b squared. And that's what we had. So we're just going in a way where we're going to factor these. Let me do some examples. Let's have say, x squared, which is a square, minus another square. Let's go with 9. Okay, we can take the square root of 9 to be 3 squared. So here we have another situation. The difference of squares follows this pattern up here. X minus 3 and x plus 3. Doesn't matter if you have the first one positive and the second one negative. I mean, they're still going to simplify the same thing. But anyway, it just follows this pattern. Difference of squares will simplify into this situation. Do not make the assumption that if you have an addition sign that you're going to have x plus 3 and x plus 3. It only works with subtraction. It only works with a difference of squares. So do not make the assumption if you have an addition sign in here that can be factored. I can do another example. Let's say we have y squared minus 16. All right, well, 16 is a perfect square. 4 and 4. So y squared minus 4 squared. Pattern for difference of squares works again in the same manner. Y minus 4 and y plus 4. All right, and that's pretty much everything that you will be using with difference of squares. In the assignment, there's going to be other factoring methods that we have already learned, and they're going to have those combined in with your worksheet on that. I want to just do a couple examples like those. So I'll leave this up here and I'll do 2 examples. If you got a handle on this, you can just go ahead and do the assignment, but I want to show you a couple examples. Here's another example. 2x to the 4th minus 162. All right, you have a couple of even numbers in there, so you know you can factor out a 2. So we'll start out with that, factor a 2 out of this. When we do that, you have x to the 4th. 162 divided by 2 is 81. All right, so then you see we can work with some difference of squares. In here, the pattern is getting close. Square root of 81 is going to be 9. All right, so then 2, you would have x to the 4th minus 9 squared. Well, we can do the square root of both of these. All right, x to the 4th would be x squared, the square root of that. 81 is obviously just going to be 9, or square root of 9 squared is just going to be 9. So I can factor this further. 2 this. 2, and that's going to be x squared minus 9, x squared plus 9. Some of you may look at this and think that we're done. We still can continue to factor this. This is not in simplified form yet. The x squared minus 9, you can look at that. It's going to be a difference of squares because square root of 9 is going to be 3. This side over here, remember, it's an addition sign. It's not going to be a difference of squares. So do not make the assumption that this one here can be factored. It cannot be factored. This one can be factored. This one, actually, I think this is one of our examples. X minus 3, x plus 3. That's this portion here. And then continue with this next one. X squared plus 9. You have 4 parts of this one are already factored, and every one of those is essential. We are done. That is finished. All right, we're just combining other things, methods that we had used factoring. I'm going to go and show you another example. Where we use other methods of factoring. All right, 4x to the 4th plus 8x cubed minus 4x squared. And lastly, minus 8x. Some of you will look at this and realize we got 4 terms up here. Let's do some factor by grouping. Before we do that, I can actually factor out something out of all of these. All of these are multiples of 4, and they all have at least an x in them. So I'm going to start out factoring out a 4x. And let's see what we get. Factor out of 4x. We have x cubed. 4x out of this. 8 divided by 4 is 2. X cubed, we take out 1, so we have an x squared. Factor out of 4x. All we left with is just an x. This divided by 4x, negative 8 divided by 4 is negative 2, and the x, take the x out, and all you're left with is just a negative 2. All right, 4x is factored out. We have 4 terms. Now let's factor by grouping. Factor by grouping on this, and let's see what we get. With this first group, let's do x squared. Okay, and we're left inside with an x plus 2. We want to end up with x plus 2 on this side. So we need to factor out a negative 1. Negative 1 over on this side. Negative x divided by negative 1 is a positive x. Negative 2 divided by negative 1, positive 2. All right, let's rewrite all this. Remember to include your 4x. So 4x. Then we have x squared minus 1. Then x plus 1. Looking at this, can we factor this using our difference of squares? Yes, we can. X squared minus 1. Bring your 4x down, include that x squared minus 1. Use our pattern. X minus 1, x plus 1, And then lastly over here we have another x plus 1. And I just noticed that should be a 2. This should be a 2 also. For some reason I called it an x plus 1. I don't know. Alright, so there we have it. This is completely factored. 4x, x minus 1, x plus 1, that came from our difference of squares. X plus 2, just carry those things down. X plus 2, there's your x plus 2. Completely factored. We are all done with this. Thank you.